Hello everyone. In this video we are going to see about the assignment problem using the branch and bound. So you know that what is the difference between the backtracking and branch and bound. Backtracking uses the depth first approach to solve the problem. The branch and bound uses the breadth first approach to solve the problem. So the assignment problem, already we have seen these assignment problems in previous method itself. So what is the assignment problem means? We have to assign a job to a given particular persons. What is our objective means? We have to assign a job to all the persons with a minimum number of hours they have to complete the jobs. So each job is assigned to each persons for optimal solutions. Suppose there are the n workers and n jobs means any worker can be assigned to any number of jobs. Our objective is to we have to complete our jobs within a minimum amount of time. So this is comes under the branch and bound technique. So branch and bound technique means it is used to solve the optimization problems. Here we are using the upper bound and lower bound solutions to solve the problems. So in that assignment problems we are using that lower bound solutions. So here also we are going to derive the state space tree. So what is a state space tree? That is a tree which contains all the solutions and non-solutions of the given problems, root as a initial node and leaf as a terminal node. For example, consider this is the problem. So in these problems we have a 4 number of persons and 4 number of jobs. So we have to assign a particular persons to the particular job. So first, what is the first step means? For a given matrix we have to find the lower bound, initial lower bound of the value. So the initial lower bound is found by, for each row we have to select the minimum value and sum all the minimum values from 4 rows. That is the lower bound of the our initial condition of our problems. So in the first row the minimum is 2. In the second row, out of 4 jobs, the minimum job is 3, and the third row it is 1, and fourth is 4. So the sum of these 4 is that 10. So this is the lower bound of our problem. So from that we start with the zeroth node. So in the zeroth node we start with the lower bound value is equal to 10. So in that first step we have to assign a job, 4 jobs to a person A. So assume that A is equal to 1, and then assign second job to one particular person A, and third job means what is the lower bound value, and the fourth job means what is our lower bound values. So suppose you are assigning a first job to a particular person A means that lower bound value is calculated by first assign a first row value to the first row value, and remaining row value is calculated by the 3 by 3 matrices. Which one is the minimum? We are adding that value, we get the value of 70. So second node, assign a suppose assume that we are going to assign a job 2 through the person A means again you have to find the lower bound value. In that the second row for a particular person A, the job 2 value is 2. So add the 2 and we have to calculate the remaining 3 by 3 matrix. From that for omitting that particular person, the A and job 2, row and columns we are omitting, we are going to find out that the lower bound value of that particular job is assigned to a person A means what is the lower bound, that is the value of 10. So again we have to calculate the same process. We are going to calculate, assign a job 3 to a particular A person A and calculate the lower bound, the value is 14, and job 4 is assigned to a person A means what is the value. So from that 4 calculations, which one is the minimum means the suppose we are going to assign a job 2 to person A, we get the lower bound value of 10. So we fix that job A to a job 2 to the particular person A. So from that again we go to the next level. Next level we are going to assign a job to a person B. So already we are assigning the job 2 to A. So the remaining 3 jobs may be assigned to person B. That is B is equal to for person B we can assign a job 1, for person B we can assign a job 3, and person B we can assign a job 4. So based on that 3 assignment, again we have to calculate that lower bound value. In that in the first assumptions, job A is assigned to 2, job 2 is assigned to A, and job is assigned to B, means what is the lower bound is, that is the lower bound value is 13. So job 2 and job 3 is assigned to consecutively A and B, means the lower bound value is 14. Job 2 to A and job 4 to B, means what is the lower bound, that is a 17. So among the 3 values, 13 is a lower bound, minimum lower bound value. So we conclude that job 1 can be assigned to we can assign the job 1 to person B. So if from that second level we came to know that job 2 is assigned to a person A and job 1 is assigned to a person B. So the next level we have to find out what is the job assigned to person C and D. So in there is a 2 options. We can assign job 3 to C and D to 4, or job 4 to C or D to 3. So based on that assumption we can calculate the lower bound value. So from that we can assign a job 3 to C and D to 4, means we can get the lower bound value of 13, and the job 4 to C and D to 3 can be assigned, means we can get the value of 25. So out of 13 and 25, 13 is a minimum value. So we conclude that job 3 is assigned to C and job 4 is assigned to D. So from that state space tree, from the root node to leaf node, we can get the solution of job 1 is assigned to A, that is the value of 2, and job B is assigned to job 1 is assigned to B, means the value is something, and then job 3 is we are assigned to C and job 4 is assigned to B, means we can get total number of 13 hours. So we can complete the job with a minimum number of hours of 13. We can assign these assumptions. So this is the way we can assign the particular job to a particular persons with a minimum number of hours. Thank you.